Welcome everyone to today's demo cast. We want to thank Progressive Railroading for having us today. And we are going to explore the building blocks that enable us to deliver on AI-powered railcar inspection. And joining me today is our Chief Technology Officer, Jeff Necciai. Jeff, when I asked you out to lunch today, did you think I was going to throw a camera in your face?
I did. I had no idea.
Okay, great. Well, for those of us out there that may not know too much about DUOT's tech and what the Railcar Inspection Portal does, why don't you give everyone a little bit of an overview there?
Sure. Well, DUOT's tech's Railcar Inspection Portal produces high-resolution images, which are submitted or available to railcar inspectors to kind of make their job easier. So they use a streamlined piece of software to be able to perform their inspections using the high-resolution images. In addition, we take the same set of high-resolution images and we subject them to our own artificial intelligence, our machine learning models, so that we can automatically detect certain defects and anomalies on those rail cars. So, you know, from a value standpoint, obviously it increases safety.
Yep.
And it increases the velocity and increases the efficiency of that inspection process. So we're real proud of the Railcar Inspection Portal and provides a lot of value out there. So
that's right. So as far as acquiring the images and the data, I mean, obviously it's not just, you know, off the shelf cameras snapping these trains coming through our portals. Why don't you talk a little bit about the sophistication there?
Yeah, sure. Unfortunately, we can't just put up a couple cameras and you know, get the kind of images we need. There's a lot more involved. We use a combination of area scan as well as line scan imaging technologies. And that's combined with a lot of devices that we have both in the track and beside the track to be able to detect things like axles, presence of axles, and the speed of the moving train, and to be able to perform car cutting, for example, between the cars. And we combine that with other collected data that we have to make a more meaningful collection of images so that they can be useful to the railcar inspector as well as our own artificial intelligence algorithms.
Excellent. So when we were getting ready for the demo cast today, we talked a little bit about some of those challenges that you and your team had to overcome, you know, to be able to deliver this type of technology to the rail industry. Maybe you can highlight some of those bigger challenges that you and the team had to overcome.
Yeah, absolutely. One of the challenges I think that becomes immediately apparent is the lack of illumination, right, at a rail site. You know, especially under the train. There's not a lot of natural light under the train. So our engineering team, just by way of example, they overcame the challenge by creating purpose-built lighting systems, purpose-built illumination that actually does exactly what it needs to do, given those high speeds and the areas which they have to image. Again, speed in itself is a challenge, right? These are higher than normal speeds. We can see 74 miles an hour, for example, on a regular freight train. That requires a very fast exposure, which requires more light. Sure. So there's very little choices for off-the-shelf lighting for something like this. So that's where our engineering team comes into place and kind of builds the things that we need in order to do what we do with imaging and artificial intelligence.
Okay. So lighting challenges, camera challenges,
there's more
speed challenges.
Yeah.
You know, to grab all that data. I mean, we're talking about an enormous amount of data with this high resolution type of images. Why don't you talk a little bit about some of the data storage challenges too that we had to work on?
Sure. When you take a look at the speed of the train, which is again higher than normal, maybe average 74, we're also working on 125 miles an hour requirement that we have for the first part of the year, which we're excited about. The speed of the capture and the amount of data, the volume of data that we're capturing requires something special, not your normal storage kinds of systems.
Sure.
So our IT department gets involved in creating those storage systems and capture systems for that. It's an enormous amount of data because we're dealing with very high resolution images. So what we call a pano image, you know, it takes the complete side of both sides of the train, the top and even the underside. Those are very, very large images. And the reason we need such large images is because our artificial intelligence algorithms kind of require 40 pixels on target for us to see certain specific anomalies and defects. So it's a lot of data, and it's always it's always a challenge.
You mentioned AI. When I'm out meeting with customers, there's a lot of interest in, Matt, what can your AI detections do to help, to speed that inspection process? Or Matt, I don't have enough labor to actually have so many people inspecting every car. Why don't you maybe tell everyone what we're doing around AI at the RIPS and how that happens?
Sure. One of the basic uses of our artificial intelligence or, this specific type of machine learning is we build models that are used to detect certain anomalies and defects on a rail car. And those defects and anomalies, they usually reflect what other regulations are. For example, the inspection points that are required by the FRA. We build models that are specifically concentrated on looking for those things. So what that means is either while or before the railcar inspector is inspecting those rail cars, we can let them know ahead of time, hey, by the way, we've detected this or we've detected that condition. And that's really the use of our models, is to be able to get that information into their hands automatically. Which obviously speeds up the process greatly.
Sure.
And makes it simple.
When I joined DUOT a few months ago, I thought it was great that you guys were developing your own AI in-house, because not everyone can do that.
Yeah.
And it's a pretty eclectic team, that helps to develop those models. Maybe you can talk a little bit about the team that you've assembled, to help to develop those AI models.
Yeah, absolutely. Well, developing a model, it starts with a problem that you have to solve, right? And not all of us in this building, for example, are experts in railcars and trains and railroads. Thankfully, we have railcar inspectors on our staff that serve as the knowledge, the body of knowledge that is required for that. And so what those railcar inspectors do is they kind of train and they guide our, well, there's a couple different teams. There's a labeling team. They guide our labeling team to be able to identify those defects themselves on images that we're producing.
Okay.
And the labeling team, they obviously label the image and they draw bounding boxes around the images. And those images are then fed into a model. Those images are referred to as a training set, but they're fed into a model, which then trains the algorithm, results in the model that actually runs in production. So there's quite a few people involved. You have algorithm developers, you have labelers, and you have the subject matter experts. They all have to come together to produce that model and make things work correctly.
Okay. Coming together as a team, it really is a team of teams then that goes out and installs this RIP. Again, coming on board here the last few months, I was really impressed with really just, again, this broad-based knowledge of a team that actually goes in and installs the RIPs. Maybe you can talk a little bit about that.
Yeah, it's an amazing, actually, a really large number of teams that are involved, and they have to be very, very closely coordinated. So we talked a little bit about the engineering challenges that the engineering team has in optics and lighting. You combine that with software, all of those devices and modules and subsystems that engineering is producing, they really do nothing without software to help them operate, right? So the software team works closely with the engineering team to make sure that all of that is orchestrated in order for us to capture the data that we need to capture. You add to that then, okay, now I'm capturing all this data. How do I store it quickly enough?
Right.
How do I store it and catalog it so that I can get back to it? And that's where our IT team comes in. They have specialized knowledge and they've worked with a lot of vendors. They build our own storage platforms that are capable to store this amount of data this quickly. And of course, on top of that, you have the AI, the algorithm development team, the labeling team that we just spoke about. And you mentioned installation. Sure. Obviously, we have an installation team that is responsible for installing the Railcar Inspection Portal. All of these folks have to work together very, very closely. And they do. We're all here in one building, thankfully. We all talk to one another. You say it's a team of teams. Sometimes we'll say it's a meeting of meetings. We have lots of different conversations. So it's important that they work very, very closely together. And that's the only thing that drives success in this business.
Yeah. So in the previous demo cast, you mentioned humans in the loop. I think for those of us joining today that maybe we're not here for the first demo cast, I think that's an important concept. Can you talk a little bit more about that?
Yeah, absolutely. Human in the loop really is what it sounds like. It's where a human gets involved in the decision making that related to our algorithms, what our algorithm automatically detected. The human will review that. Now we use that in two cases. Well, for two reasons. Number one, we use it for the continuous improvement of our algorithms. We are dedicated to continuous improvement. It's a continuous learning experience. That is, our algorithm is constantly being retrained to get better and better and better at detecting things. The other reason we use it is for new algorithms that are recently introduced into production, just to keep a watchful eye on the decisions that are being made automatically. So we use humans in the loop in those two ways. And the advantage there, obviously, it allows us to achieve and keep at least a 95% or higher accuracy on every algorithm that goes into production.
That's an incredible accuracy amount. I mean, I've been, having discussions with customers around automating the inspection process. They can't fully go to automation unless those accuracy rates are at that 95+%. So kudos to your team for that. Centraco, let's let you mention software previously. I think about one of the things that I was really blown away with coming on board was when, one of our railcar inspectors had sat me down and took me through the Centraco system. The idea of capturing these high resolution images in tough environments and being able to send it in near real time to our customer's desktop in order of concepts that train is coming through. That's just incredible. Maybe you can talk a little bit more about the browser-based, user interface that we have called Centraco.
Yeah, absolutely. It is. And Centraco is, it's what I call the business end of the solution, because it's what our users and most of our customers, it's what they see in their minds when they think of the Railcar inspection portal. It's what they remember mostly because it's very visual. And, it's a streamlined user interface. To your point, like you said, it basically allows a railcar inspector to pan through every railcar within a consist, and they can see any type of perspective that we have. And I should say that we have multiple perspectives. I think that there's a minimum of 9 perspectives: the top, the sides, the bottom, and they cover. There's nine of those that cover that, even the underside.
Sure.
And it allows them to pan through those and zoom in and zoom out and actually look at the area of interest that they're interested in. And it streamlines that work. It speeds up that work quite a bit. The other thing it allows them to do, it allows a railcar inspector to make annotations with regard to something they may see. Maybe we didn't have a model in place for a specific detection, but it's part of their job to detect that certain thing or to inspect and find that certain anomaly. They can make that part of the inspection record with Centraco. And it's just a real easy to learn. The learning curve is very, very low on it. And we get very, very
even
good
a sales guy can learn it, right?
Yeah, absolutely. Yeah.
Okay, so we've talked a little bit about how we acquire the data and the images, then AI, how we're analyzing it, Centraco, how we present it. You're a customer, you say, hey, that's great. We've got this back office. We have to generate work orders. How does Centraco or how does DUOT then get that data feed to those back office?
Yeah, absolutely. The other thing we're real proud of is we have a data exchange system that's kind of built on a templatized system that we've developed in-house. Because we know it's important to share data between one system and another. No system exists in a complete vacuum, right? And we understand that work orders are being created and managed by third-party systems and by customer-built systems. And so we exchange data in multiple formats all the time, everywhere from JSON and XML, all the way up to flat files and CSV files, if you will. But both the transport and the format, they're very, very flexible. And it's almost all of the data that we've collected in the system, all the data that we generate in the system about a specific, what we're calling a passage or a train coming through. All of that is available, again, in close to real time. It's right after the train leaves, all of that information is available. And that includes detections that were made by our artificial intelligence algorithms.
You mentioned the 9 different views earlier when looking at Centraco. Maybe we can touch upon just a little bit about modularity and subsystems. If you're a customer who, hey, Matt, that's great. I don't need all 9. I just want a top, maybe bottom, maybe a side panel. Can you talk a little bit about that?
Yeah, early on, we realized that not all the customers, one size doesn't fit all. Not all customers need the exact same thing. And so we built our system to be very, very modular. We do have a core set of cameras. I think we mentioned the 9, but we have modules which consist of high obliques. We have top coupler cameras, which is a module. It's not necessary unless you want one. We have the view, which we're very familiar with. I mean, it shows the underside of the rail car, which is extremely important and valuable. And we have the oblique view. And I want to speak a moment about obliques. The oblique cameras are at a different angle. They're severely angled, and they're supposed to be that way. That's by intention. It's different than our panoramic cameras, which are they look at a side right on, for example. They look at the object in perpendicular to the object. With an oblique image, you get a little bit of shadow and a little bit of depth, and that's what some of our artificial intelligence algorithms are looking for. That's what they need. So we use a combination of both, but all of these things are modular. They're modular. So as a customer, you may need an oblique view. You may not need an oblique view. And we understand that. And the system it's not what I would consider to be completely plug and play, but it does approach that architecture to the extent possible.
Can you talk a little bit about, well, you mentioned the different AI models that we currently have, maybe your thoughts on developing additional AI into 2023 and maybe touch upon any other type of emerging technologies that your team is currently working on?
Yeah, so we have a catalog of artificial intelligence algorithms that are ready. We refer to them as on the shelf or in the can. They're ready to be purchased and implemented by any railcar inspection portal customer. Again, approaches kind of like the plug and play architecture that we were talking about. We worked to make sure that was very flexible in being able to do that. So obviously our model development team is constantly working on new models along with the railcar inspection portal, railcar inspectors, our mechanics. They're working on new algorithms, and we have lots planned for the following year. There's new technologies too. I mean, we have a dedicated research, development, and innovation department, and they are, dedicated to looking at new and emerging technologies and how that technology can be applied to the railcar inspection portal. Everything from, the thermal cameras that we're dealing with now to spectral imaging and some other things that we want to do in the future. So it's 2023 is looking good for the roadmap. We have lots that I'm sure we'll talk to folks about in the future.
Excellent. Well, that's it for now. We can take a few questions. I'm going to just take it from the top. Jermaine Walker asks, can this technology help transit agencies, or can it be fitted to work on transit properties? That's actually a really good question. And Jeff, you hit upon earlier, speeds up to 125 miles per hour. That's certainly not freight, right? So why don't you talk a little bit about maybe some of the transit?
So that is the 125 miles an hour is for passenger rail. And we certainly have the solution is designed for transit as well. It's a different set of some of the models that we have are shared between transit and freight, but most of them are different. So yeah, absolutely. We had to look at speed. The trucks are different on passenger rail, and so we had to align some of our cameras a little bit differently, and so we can do the capture appropriately. But certainly we support passenger rail and transit.
And with transit sometimes comes pantographs. Can you talk a little bit more about what we're doing in that space?
Yeah, we have a couple of customers that have our basically a subset of our system that does the pantograph, and we're doing those inspections. It's the same thing. It comes through Centraco. They can do their inspections the same way,
Excellent.
and they can look at the entire pantograph.
Okay, great. Thanks, Jeff. Okay, Daryl Kruger asks, you mentioned a requirement for 40 pixels on target. Could you elaborate? What does that translate to in terms of inches per pixel or pixels per inch at the nominal focus distance in the center of the image? So great question, Daryl.
Wow.
Jeff?
Yeah, Daryl, that's a wonderful question.
Again?
Boy, you got me on this spot. I'm not actually sure what it translates to as far as the measurement is concerned. You know, just at a high level, the 40 pixels on target is a way, it's a measurement that our team uses to make sure that when we utilize the image, we have enough image data to be able to recognize that pattern. So our labeling team has to make sure that that's correct and that they have enough to be able to pick out of that image. But more importantly, the algorithm itself, as it's doing its pattern recognition and it's picking some pixels apart, it has to have enough to deal with. The engineers back in the algorithm development lab over there, they would probably be able to give you that measurement, but I don't have the actual measurement translation here.
Okay, Daryl, we'll try to get you a little bit more meat on the bone there.
Yeah.
Lastly, are only object detection bounding box models available? That's a really good question.
Are only detection bounding box
Meaning,
models
I take that as our AI only providing a bounding box of a potential defect, and I think we get a lot more specific than that.
Yeah, we do. The bounding box, when I referred to it, I was referring to one of the things that the labeling team does to prepare the training or the learning set. The bounding box that we draw on our result is, it certainly does bound the area of interest because we want to show the anomaly and the defect, but there's data that comes along with that. For example, you know, we have one customer up north that is, when they're looking at sill steps, for example, they want to see the bent sill step, but they really want to know how bent. And we can provide that information, and we do provide that information. So there's lots of what we call metadata along with the detection that would actually help.
Excellent.
Hopefully that answered the question. Again, we're happy to talk offline.
Yeah, we'll grab these users and make sure that we get their full answer. But Jeff, thanks for joining me today. Again, thanks to Progressive Railroading for having us. For additional information on Duos, you can see us at www.duostech.com. You can find us on LinkedIn. And if there's any additional questions here from today's demo cast, please feel free to send an email to sales@duostech.com. We'd be happy to answer any additional questions. So thank you again for having us.
Thank you.